Hey there, kiddos. In this lesson, lesson 5.3 for Math 6, we're going to learn about the properties of addition and the properties of multiplication. Our learning target for today, our learning objective, is that we want to be able to identify equivalent expressions and apply properties to generate equivalent expressions. And so when it comes to expressions, we know that those expressions are going to have constants, coefficients, and terms. So some key vocabulary that you're going to want to have in your composition notebook or your 3-ring binder is that expressions that result in the same number for any value of each variable are equivalent expressions. And hopefully you recognize that in the word equivalent is that word equal. You can use the commutative property and associative property to write equivalent expressions. When it comes to commutative property, think of a community where you can change the order, go up the street 1 2 3 4 5, or go down the street 5 4 3 2 1. The homes and who lives in those homes are still the same. So commutative property means that we can change the order, but the value of that expression is still going to be the same. Associative property is that, hey, we can use parentheses or grouping symbols so that we can perform certain operations first before others. So once again, like we were saying, 1 plus 2 plus 3 plus 4 plus 5. If we just sort of group to 1 plus 2, that equals 3. And then we put parentheses around 3 and 4. 3 plus 4 equals 7. And then plus 5. So we can then have a new expression or an equivalent expression of 3 plus 7 plus 5. And it's still going to give us the same value for each of those expressions. And those expressions would be equivalent. Let's see what I mean. So as we were saying, commutative property, changing the order of the add-ins or the factors doesn't change the sum of the product. In associative property, we can use grouping symbols around the add-ins or the factors. And again, it doesn't change the sum or the product of that expression. Here's an example. Example number 1. Use properties to write equivalent expressions. Well, we see in example letter A that there are parentheses. Remembering our order of operations, whatever is in parentheses is what we would do first. And so if we wanted to simplify this, well, are there any like terms between 12 and x? The answer is no. There are no like terms in the parentheses, so we're going to look to see, hey, what are the like terms? What is the same in this? And well, there are two constants. The constant of 7 and 9. 7 plus 12, which give us 19. And then x is a variable, so it's not the same. So it's just going to rewrite this as 19 plus x. When we look at letter B, again, what are the terms that are the same? 6.1 is a constant. 8.4 is a constant. X is a variable. So we can add the two constants together. So 6.1 plus 8.4, that's going to give us 14.5. And x is by itself. So that is the equivalent expression. X plus 14.5. They're two different things. We have constants, and then variables. We don't add the constants and the variables together. We just leave them as they are. However, when we are multiplying, that's something different. When we're multiplying, we can. And in this case, 5 times 11y, well, 5 times 11 is 55. So 55y. That is an equivalent expression to what we saw before in letter C. Pay attention. When we are adding, we're not going to be combining our terms of constants and variables, whereas if we're multiplying, that is different. When we're multiplying, we can multiply constants and variables. All right, let's see how this applies in another example. All right, using the property to write equivalent expressions. Well, when we look at letter A, simplify the expression. 9 times 0 times p. Hopefully, the moment you see that 0, you're remembering it to yourself and saying to yourself, well, anything times 0 is going to be equal to 0. Well, 9 times 0 is going to be 0, and then 0 times p, that's equal to 0 as well. So this is just going to be 0. What about letter B? Again, remember multiplication. When we can multiply a constant and a variable. So here we can simplify this expression by taking the two constants, 4.5 and 1, multiply those two. 4.5 times 1 would just be 4.5, and then 4.5 times r is just 4.5 times r. And we rewrite that as 4.5 times r. We don't need the multiplication symbol in between those two. So far, so good? Thumbs up? Alrighty, let's move on to number 3. Example number 3. We want to just remember, as we were saying before, anytime you're adding 0, that doesn't change your expression. And anytime you multiply times 0, that's just going to be equal to 0. And anytime you multiply times 1, it's going to give you the same. These are just key reminders that we want to keep in mind as we're going through and as the car is going by. So you and 6 friends play on a basketball team. A sponsor paid $100 for the league fee. There are X amount of dollars, so we don't know how much dollars that is, for each player's t-shirt. And then $68.25 for the basketballs. We want to write an expression that represents the total amount in dollars that the sponsor paid. Then find the total amount paid for each t-shirt, which costs $14.50. So what do we know? Well, we know that we want to find the total amount in dollars that the sponsor paid. And we recognize that there's the league fee, there's the cost of the t-shirts, and then the cost of the basketballs. So what do we know? We know that the expression for the cost of the t-shirts is going to be represented by X, and we know that X equals $14.50. What else do we know? We know that the league fee is equal to $100. And finally, what is going to be the cost of the t-shirts? The cost of the basketballs. So we have league fee plus the number of t-shirts times the cost of the t-shirts is going to give us the total cost of, plus the basketballs will give us the total cost. So what do we know? League fee, $100. Number of t-shirts is what? Is it 6? No, it's you and your 6 friends. So we want to pay attention to that. So that's going to be equal to 7. What are the costs per t-shirts? Costs per t-shirts are told is X, but we're then told that X is equal to $14.50, and then the cost for basketballs is $68.25. So now that we have our expression, we can write this out. Commutative property, change the order so that we have our constants together and we have our coefficient and variable off to the side. Use the associative property to group together 100 plus 68.25. It just makes it easier for us to work. So we add those two together, will give us 168.25. And then we know that there are 7 t-shirts that we need to purchase because there are 7 people on the team. And if X is equal to $14.50, well, we can now multiply 7 times $14.50 to figure out the total cost for the t-shirts and all the fees and the basketball. And that's going to give us a grand total of $269.75. So our expression that would represent that total amount would be 7 times X plus 168.25, or $168.25. Let's just pause for a moment. I know there's a lot on the screen. There's a lot in that PowerPoint. Do we recognize each part of that expression as to how we got to the final expression? The fee, number of t-shirts, cost of the basketball, and then cost of the t-shirt. If you could identify those 4 things, then you could write this expression. Remember, because of the commutative property, if you didn't write this in the exact same order, that's okay, because we can change things around because of the commutative property says when it comes to addition, that's not going to change the sum. All right? Excellent. So now let's get to our classwork.